everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. So first of all, welcome to my class. So today we are going to discuss about the reluctance motor. So this is a one special kind of motors. This is this reluctance motor is a combination of the property of single phase induction motor and synchronous motor. So you can say that it is a single phase synchronous motor. So how we know that in case of single phase induction motor, the rotor cannot attain the synchronous speed, but in case of this reluctance motor, how after applying the single phase, how this rotor is achieving uh, synchronous speed, and then what are the applications we have this reluctance motor. Those are very important things regarding this. Then to do achieve that synchronous speed, what are the constructional features it has for this particular machine. So that understanding is very important. Okay, so let us start further to this presentation. So this is the uh, first, before starting the what is the constructional features property it has. So first we are going to first we have to know that what are the applications of this reluctance motor. So we know that reluctance motors are used where we in different low speed, low power factor cases we can use this reluctance motor. So automatic regulator, recording instruments, teleprinters, timer circuits, recording instruments, signaling devices. So these are the places where we can use actually this reluctance motor. So let us see that what are the constructional features it has. So as we know that synchronous, so first as you can see in this particular diagram, so there is a diagram of synchronous motor. Now the point is, synchronous motor has a slotted inner periphery stator, and inside that we have a rotor, maybe of saline pole type or a cylindrical type. But in this particular diagram we can see a saline pole type rotor. Okay, now we know that in case of synchronous motor, it either can run at synchronous speed or it cannot run. Okay, so that's why there is a characteristics like this way. So this axis is the speed axis, this axis follow my pointer, this axis is the torque axis. So either it has a speed, constant speed, or it has a zero torque. Okay, so with the changing speed it has a constant torque, but when after a certain value, when it is when its speed is such a value, which then at that time it cannot synchronize with that synchronous flux, so it will stop rotating. So we have to take in mind from the concept of synchronous motor is that the reluctance motor that we are going to discuss today, that should have rotate at synchronous speed. Okay, so the starting of synchronous speed is that synchronous motor is that we know that in the stator section where we have the three phase armature binding, where there we give three phase AC supply, and in the rotor section where we have the pole, saline pole, so there we give a external DC supply, and with that we rotate that field winding or rotor section by means of some external devices or prime mover. But in case of reluctance motor, we doesn't have any winding over the rotor. First case. Next thing is that we doesn't have to rotate the rotor by some external means or by some prime mover. Those are the very important point that you have to remember. From the, this is the difference from the synchronous motor to the reluctance motor. So in synchronous motor we have to give some DC supply, we have over the field winding of rotor, and that means over the rotor we have a winding. That point, one point. And number 2 point is that the rotor achieves its synchronous speed by means of some external devices. But in case of reluctance motor, it doesn't have something like that. That means it over the rotor, it doesn't have any winding, and second thing is that it doesn't need any external devices or prime mover to attain the synchronous speed of this reluctance motor. So how they work, so that is the important issue. So yes, this is another thing. So induction motor property. So a very interesting thing is that reluctance motor is a combination of the both property. That means in synchronous motor property, induction motor property, all combining a special machine, that is the reluctance motor. So what is there in the induction motor? Basically single phase is applied, and due to that what is happening, um, we know that in single phase induction motor, in the stator section we have two kinds of winding. One is the main winding, one is the auxiliary winding or starting winding. So we know that if we only use the main winding, we cannot generate the rotating flux so that the rotor can start rotating. So it is generating the pulsating torque. So that's why we have to use over there auxiliary winding, so that the speed can be the phase can be splitted, and the whatever flux is generated, that should be rotating in nature, and due to that the rotor starts rotating. So considering this concept, we have to think of the reluctance motor. That means here in the reluctance motor also we are going to use this main winding and auxiliary winding. Both winding will be there, otherwise it will not start. And after that, in case of induction motor, we know that rotor starts rotating after that, and the rotor speed is always less than the speed of the flux, that is a synchronous flux. But here there is a change in the reluctance motor, that here in case of reluctance motor, it will definitely rotate at synchronous speed. Okay, so have you got the idea? That means we are going to design a motor which at which we are giving single phase supply, which has no winding over the rotor, which should be rotated at the synchronous speed. Okay, so these are the property of say reluctance motor we have. Okay, so let us see. So before starting that reluctance motor, there are the differences. See, in this particular slide we can see the different types of special types of machines that we have in the motor. So one by one we are going to discuss all the motors. So basically this reluctance motors can be of two types. Okay, so what are the types? Or there are four types actually, not two types, four types actually. So one by one we are going to discuss today. So first, see that reluctance motor, a synchronous induction motor. The rotor has saline poles and a cage, so that it starts like an induction motor and runs like a synchronous motor. So that means two properties are combined together. So hysteresis motor, it is one type of reluctance motor. So hysteresis produces the torque and can be very teeny, used as the driver for electrical clocks. Stepper motor, so a special type of synchronous motor, rotates a number of degrees with each electrical pulse. Brushless DC motor, a close cousin of a permanent magnet stepper motor with electronic controllers. And universal motor, so those things, within those things, already we have discussed about the universal motors, stepper motors, brushless DC motors. So we know that those things, just classification is given over here. So if a series DC motor has a laminated stator frame, it will run efficiently from an AC supply as well as DC. This is the universal motor. So we are not going for details, so we should concentrate what is reluctance motor. So to do that, first of all we have to know what is this magnetic reluctance. So basically, by definition, if we want to say, so magnetic reluctance is basically the opposed offer towards the magnetic flux. So as in the electrical circuit, the property of resistance is to oppose the flow of current. So like in the magnetic circuit, when the some fluxes are there, and when some opposed is offered to the flux, that means when the fluxes are opposed to flow, so that property of the system is known as the reluctance of the system. And using that property, that means, so we can say that if a reluctance value is high, so less flux can flow. If the reluctance value is very less, so higher current can flow. So depending upon this property, we can design this reluctance motor. So let us see how we can think of this machine. Reluctance motor. So an induction motor with a modified rotor can be used as a reluctance motor. So it can be of single phase or three phase. So in our syllabus particularly we have the single phase reluctance motor. Rotor turns in synchronism with the rotating magnetic flux. Now it is a motor which depends on reluctance torque of its operation. Reluctance torque is the torque induced in an iron object in the presence of external magnetic field. Okay, so let us consider the construction. So if we able to understand the very purely what is the construction is, then we can very well understand what is the working principle of this reluctance motor. So as we can see, so in this reluctance motor, obviously we know that any rotating machine has two parts. One is the stator, one is the rotor. So this follow my pointer. This is the stator section, over where we have the winding. These are the windings, and this is the rotor section which is rotating. Now this rotor is something like that, this way. Follow my pointer. This is the rotor section. So this periphery are like slotted like this, and it is something like that, the cage rotor, but it is not continuous. There is a symmetrical gap in between them, so that it can be works as at the saline pole type rotor. Okay, so that's why intentionally this portion are kept blank. Now after so that means there is simple stator is there, and there is the rotors peripheries, the slots, armature slots are slotted, so that there is a good magnetic strength in between them. Now the point is how the reluctance is affecting the working principle of this reluctance motor. So to understand that, first of all we have to go back to the school level physics. So in school level physics we have understood that what is the ferromagnetic material, what is the diamagnetic material, okay, what is the insulator. So we have seen that a material through which has a very high numbers of free electrons, through which a high current can flow, through which a magnetic field, a high strength magnetic field can produce, that is the ferromagnetic material. So in case of this reluctance motor, whatever rotor we are using, over the that rotor material should be a very good quality ferromagnetic material, and over the rotor there should be no winding, only a rotor which has a very good property of ferromagnetism. Now after that, how it is working. So how it is working, so before, okay, so let us try to explain over here. So say, follow my pointer very carefully. Say we are giving a single phase supply to this tracer section. So definitely when some current is flowing through some winding, there will be a flux generation, correct? When there is a flux generation, so, and we have considered that in the case of stator construction of this reluctance motor, we are using how many types of winding? Two. One is the main winding we are using, and the second one is the auxiliary winding we are using. That means what? That means it is generating a rotating magnetic flux, and obviously due to that the rotor will start rotating. So initially the rotor speed nr should be less than the ns, that is the synchronous speed, as per the concept of three phase induction motor or single phase induction motor. Now due to the property of the ferromagnetic material, so obviously there is a generation of opposite pole. Follow my pointer. So say here we have a north pole, Okay, and here these are the ferromagnetic material, this is the rotor. So here maybe there is a generation of south pole. Okay, so what will happen, so the flux will try to flow like this. So flux will try to flow like this, when and the why, and when the flux is trying to flow through this ferromagnetic material, as it has very less reluctance with respect to this air also. Okay, that means when we are using a ferromagnetic material which has a very low reactance with respect to air, that time what will happen, the flux will not go flow through the uh, air, it will flow through the ferromagnetic material, because it is easier for that flux to flow through it, one as like the resistance. So say if we have a two resistance, one 100 ohm and one is 1 ohm, so through which higher current will flow, through 1 ohm, because through 100 ohm if the current is trying to flow, it will opposed. Okay, so that's why here also the same funda, that magnetic flux will flow through which one, which has a lower reluctance. So the machine has a lower reluctance, the rotor section has lower reluctance, so the flux will try to flow, and it will flow through the rotor section. And when, follow my pointer, when the flux is flowing like this through stator pole to the rotor pole, so what will happen, there is a magnetic attraction, and due to that there is a magnetic locking. And when this magnetic lock is happening in the reluctance motor, so what will happen, so the rotor will start rotating at a speed the flux is rotating. And at what speed the flux is rotating, it is rotating at synchronous speed, so the rotor will also start rotating in the synchronous speed. So this is the basic working principle of reluctance motor. So we should say a single phase supply is given, due to that some fluxes are generating, and as there are two windings in the stator section, there is a main winding and auxiliary winding, there is a rotating magnetic flux is generated, and due to that rotor starts rotating. And now as the from the air gap, the rotor ferromagnetic material has a lower reluctance, the flux will try to flow through the rotor poles. So when it is tried to flow to the rotor pole, it will attract the rotor poles, and there will be magnetic locking, and due to that the rotor starts rotating at the speed at which the flux is rotating, that is the synchronous speed. Okay, so this is all about the how they work. So now the operation, the torque applied to the rotor is proportional to the sine 2 delta. Delta is the electrical angle between the rotor and the stator magnetic field. Okay, so as we can say that yes, this one, see there is an angle. Okay, this angle is this one. Okay, the maximum torque angle will be 45. If it is more than that, then it will not synchronized. Now this is the switch, there is a diagram that one is representing the switch reluctance motor. So like this way the constructions are done, where this picture we can see that. So starting, how we should start, like a normal synchronous motor, it has no starting torque. Yes, definitely it will not start, it will not start by itself, it will start an induction motor. And for better starting torque, we use this auxiliary winding, as we have discussed already these things. So this is a torque speed characteristics, it start like an induction motor and works like a synchronous motor. Therefore it is also known as induction synchronous motor. The starting torque is highly dependent on the position of the rotor. Okay, so here as we can see that the torque versus speed characteristics. So one is showing us the main winding characteristics. This dotted one is representing the main winding characteristics, and this line is representing the main and auxiliary winding characteristics, and this is the line which is switching speed. That means when the centrifugal switch is disconnected from the circuit, where those things we have discussed in the single phase induction motor. So it is the characteristics that we are discussing. So now see what are the application of this reluctance motor has. It is analog electrical meters, washing machines, hard disk drive motors, sewing machine motors. So there are different application we have. Okay, now also we know that it can be applied in the automatic regulators, recording instruments, teleprinters, timer circuit, signaling devices. and according to the working principle it can be of different types. What are the types? There are the four types of machines that I have already told. So now I'm going to tell you what are the different types of different types of reluctance motor we have. So the synchronous reluctance motor we have, okay, then I have variable reluctance motor we have, then switch reluctance motor we have, then have variable reluctance stepped motor we have. So in the next presentation or next to next presentation we are going to discuss all those reluctance motor one by one. So for this particular presentation I have discussed about the only reluctance motors, how they works, what are the constructional features it has, what are the application it has. So this is all for today. I think now you are able to understand what is the reluctance motor, what is reluctance basically. So after that you have to understand combining the two working principle of two machines. One is a single synchronous motor which is rotating at synchronous speed, and the concept of induction motor which is supplied by single phase source, and by using the magnetic main winding and auxiliary winding, how they are started. So combining those principle, and the main thing is that we are using single phase supply, but the machine is rotating at synchronous speed, and at the same time that this machine has a very low reactance. That's why it doesn't need any winding over the rotor, and just by the magnetic locking the motor starts rotating. So but it has some disadvantages, because it has very low power factor, it is very low efficiency. So it is used for the small cases where we need a small motors for this particular application. So this is all for today. Thank you.